Fjords are effective carbon traps regardless of oxygen levels, a new study finds. This is a photograph of the Fjords in Swedish Bohuslän, and it was one of the fjords featured in this study. This fjord has a varying oxygen content. Hello folks, Jim here. Welcome to Science Talk. The fjords on Sweden's west coast act as effective carbon traps regardless of whether the bottom water is oxygen-rich or not. This is the conclusion of a new study by researchers from the University of Gothenburg. The paper is published in the journal Geophysical Research, Biogeosciences. Large quantities of plant parts sink to the bottom of fjords on the Swedish west coast, where they form sediments. This buries organic carbon, which would otherwise contribute to ocean acidification and the greenhouse effect. When the plant parts are exposed to oxygen and other substances, the organic carbon begins to decompose into inorganic carbon, which can be dissolved into carbonic acid in the water. Research has previously assumed that it is the oxygen content of the bottom environment that determines how effectively the carbon can be captured, but measurements in 3 fjords in Sweden show that oxygen content plays less of a role. They notice the same pattern in 3 fjords. We chose 3 fjords with different oxygen levels in the bottom water, and for these fjords, it seems that the amount of particles that settle is so high that the impact of oxygen on decomposition is low, says Per Hall, Professor Emeritus of Marine Biogeochemistry at the University of Gothenburg and a co-author of the study. The 3 fjords, Björnfjorden, Hakafjorden, Gullmarsfjorden, shows the same pattern in the sediments. Large amounts of organic carbon are stored, and decomposition proceeds at the same rate whether plant parts from land or sea have landed on the seabed. That's interesting. This is also new knowledge. Further into the fjords, the proportion of terrestrial plant parts is greater in the sediments than further out in the fjord closest to the sill. But as a carbon sink, the fjord works equally well everywhere, regardless of the origin of the organic material, said Professor Hall. Mineral particles also contribute to the carbon trap. Another thing that could be noted in the measurements was that the organic material combines with mineral particles that are transported out into the fjord by water courses. This association makes the organic matter sink faster and slows down decomposition because bacteria and other organisms cannot break down this material as well, and thus it contributes to the carbon sink. Fjords are the marine environments that bury the most organic carbon relative to their size. Let's highlight that. This is very important. Fjords are the marine environments that bury the most organic carbon relative to their size, about 18 megatons of organic carbon are buried in fjord sediments globally each year, representing 11% of all carbon captured in the world's oceans, even though fjords account for only 0.1% of all ocean surface area. This is important. This needs to be highlighted and repeated. About 18 megatons of organic carbon are buried in fjord settlements globally every year. That is 11% of all the carbon captured in the world's oceans, even though fjords only comprise 1/10 of 1% of all ocean surface area. Therefore, we conclude that fjords, especially those located in a temperate climate with surrounding terrestrial vegetation that can contribute to fjord sedimentation, play an important role in climate regulation on longer timescales. This emphasizes the importance of exploring these ecosystems in the context of global change, says Professor Hull. Well, this is an interesting finding, and it's important. And there's a couple of things that warrant further research in my view. One is this whole process, but the second is the role of mineral particles. What they're implying here is that when the mineral particles somehow combine with the organic material, it slows down the decomposition, enhancing the burial of organic carbon, the sequestration, if you will. What happens in regions, near shore, what have you, where the mineral particle concentration or the amount is far less? If this study is to be extrapolated, then the implication would be that more of the material would be broken down. So this is another aspect right here, the mineral particles, that needs to, in my view, be investigated further. So, does this solve everything? Well, of course not. I mean, fjords, despite this small ocean surface area, do capture, do bury 11% of all carbon. Well, that leaves 89%. And how is that 89% distributed? What are the processes with that? I've discussed with you, for example, marine snow and thermohaline flow, all that kind of processes, especially over the deep ocean. You've got processes on the shelf, you got processes on the slope. It depends on the physics, really. Is there an upwelling regime? Is there a downwelling regime? Are there turbid flows or not? So we have to, in order to ascertain how much carbon is being buried, you have to understand better the physics in the location you are studying. You have to understand the physics better, as the physical mechanisms will ultimately determine what happens. So anyway, just wanted to share this with you. I found this to be interesting. There are other things such as eutrophication, if that will have an adverse impact on this process or not. But very interesting finding, and we'll see what further research reveals. So until next time, thank you for your time.